Question 2.28. 2-point charges are placed at two of the corners of a triangle as shown in the figure. Find the magnitude and the direction of electric field at the third corner of the triangle. So here we have two charges, let's call them Q1 and Q2, which are placed at two corners of a triangle. Magnitude of charge Q1 is negative 10 microcoulomb, which you can write as negative 10 times 10 to the power negative 6 coulomb, whereas charge Q2 is positive 15 microcoulomb, that can be written as 15 times 10 to the power negative 6 coulomb. And we need to find electric field at the third corner. We can call this corner as P. We need to find what will be the net electric field at point P because of these two charges. So let us first sketch the direction of electric field at P because of Q1 and Q2. Now since Q2 is a positive charge, field lines due to a positive charge will go away from the charge. So electric field due to charge Q2 will be going to the left. We can write this as field E2. Q1 is negatively charged and electric field lines point towards the negative charge. So at point P, field line due to Q1 will be pointing towards Q1. We will call this E1. The net electric field has to be a vector sum of these two. So since these two are perpendicular to each other, we can use the law of parallelogram to show the resultant of these two, which will be along the diagonal in this manner. So this is my E net. I need to find the value of E net. So to get the net electric field, let us first find what is E1, E2, and then we can use Pythagorean theorem to find the resultant. So let's start with E1. E1 will be the magnitude of electric field due to charge Q1. We can write this as K Q1 over R1 squared. R1 is the distance between charge Q1 and the point P, which they have given here as 10 centimeter. And 10 centimeter, you can write it as 0.1 meter. So let's substitute. K is 9 times 10 to the power 9. Since we are finding only the magnitude of electric field, we will not put the minus sign on the charge. The direction is later given by using vector and not the sign on the charge here. So let's just put only the magnitude of the charge, which is 10 microcoulomb. So 10 times 10 to the power negative 6 over the distance, which is 0.1 squared. That gives me E1 to be equal to 9 times 10 to the power 6 Newton per coulomb. Then we do the same thing to find E2. E2 will be equal to K Q2 over R2 squared, where E2 is electric field due to charge 2 at point P. R2 is the distance between them, which is 20 centimeter, and you can write this as 0.2 meter. So we get this 9 times 10 to the power 9. Magnitude of charge Q2 is 15 microcoulomb and the distance between them is 0.2 squared. That gives you E2 as 3.375 times 10 to the power 6 Newton per coulomb. After we get these two values of electric field, now we find their resultant. The resultant electric field we can find by using Pythagorean theorem. I'm only using Pythagorean theorem here because these two electric fields are perpendicular to each other. If they were not, then we use vector sum. And later, if it is in two dimension, after doing vector sum along each axis, we use Pythagorean theorem. So let's start. E net will be square root E1 squared plus E2 squared. That will be equal to square root E1 is 9 times 10 to the power 6 squared. E2 is 3.375 times 10 to the power 6 squared. Make sure you take the square of the power also along with the number. That gives you the net electric field to be 9.6 times 10 to the power 6 Newton per coulomb. This is just the magnitude of the field. Now we need to find its direction. Direction we find using tan inverse. So theta will be tan inverse y component over the x component. Here the y component is the component that goes along y-axis, which is E1. X component is E2. So we get theta to be equal to tan inverse E1 is 9 times 10 to the power 6. E2 is 3.375 times 10 to the power 6. That gives me the angle. Make sure you're using your calculator in degree mode while calculating this angle. This will become 69.4 degree. But this angle is with respect to the negative x-axis. When I'm finding theta using tan inverse, it's the angle resultant mixed with the x-axis, whether is it positive or negative. But we generally find angle from the positive x-axis. So I want this angle over here. And this angle I can find theta final by just subtracting theta with 180. So I get 180 minus theta, which will be 180 minus 69.4. That should give you 110.5 degrees. So this is the magnitude and direction of electric field due to the two charges at point P or at the third corner of the triangle.